In our quadratics unit, we've learned about standard form and vertex form, both very useful forms of a quadratic, but today we're going to be learning about what's called intercept form. Now this is going to look very familiar to something we've already done because I spent a while calling this form factored form. So if you want to think of intercept form as factored form, it's going to look very similar to when we solved quadratics by factoring. But in fact, this entire form of a quadratic tells us a bunch of information. So the same way that vertex form told me the vertex and axis of symmetry, the intercept form of a quadratic is going to tell me the intercepts. Okay, this P and Q that is blue in this equation, f of x equal to a, parentheses, x minus p, close parentheses, x minus q, close parentheses, those P and Qs are my x-intercepts, which is why this is called intercept form. Now what's cool is since we know that these are the x-intercepts, we also know that they're the roots, the zeros, and the solutions, which sounds very familiar because when we wrote factored form equations, we always had our solutions right afterwards, where x is some number and x is some number. That's what we found when we solved by factoring, and in fact, we can use intercept form to graph and find these intercepts, which is still just the solutions. Another cool thing that intercept form does tell me, since there's an a value right here, if you remember in vertex form, that first number a, it's going to be the same number, tells us some information about the transformation applied. Now this only tells me about the stretches, shrinks, and reflections, because remember, if the absolute value of a is greater than 1, meaning that this is a Dolly Parton fraction, okay, so like any number bigger than 1 is a Dolly Parton, that this is going to be a vertical stretch, and that if a is anything between 0 and 1, the absolute value, meaning it's a J-low fraction, that it's going to be a vertical shrink or compression. Now that's not as important as the next little piece. This next little piece that's written in green is so important because we're going to be able to eliminate answer choices on, let's say, a star test, given knowing that if the parabola should be positive or negative, and that has everything to do with a. If that a value is negative, this should be reflected in the x-axis. Which means we'll have a sad parabola. So if that number is positive, we'll have a happy parabola. That's not how you spell parabola. Let me try again. And if you have a negative number, it's a sad parabola, which is great because we'll be able to look at graphs and know if it should be positive or negative depending on what the parabola looks like, if it's happy or sad. Cool, so let's see what questions might look like and what kind of informations we know from intercept form. This right here is intercept form. G of x equal to -2, open parentheses, x minus 5, close open, x plus 3, okay? That's my intercept form equation. I need to figure out how to fill in these sentences. It says the transformations applied are a blank across the blank. Well, we know that since this is negative, that this is called a reflection across the x-axis. It's going to flip over that parabola. It's going to be a sad parabola. And because the a value or number in front of the parentheses is 2, that's a Dolly Parton number, that means that this is going to be a vertical stretch by a factor of 2. Now that's great. So I know it's going to be flipped over and narrow, more narrow than the parent function. I also know automatically what the roots, x-intercepts, roots, zeros, x-intercepts, and solutions are. But just like when we did solving by factoring and we have factored form, the number that we're plugging into the equation changes because a minus sign is in the equation already, and minus a minus is plus. Which means the zero product property tells me that the roots, zeros, x-intercepts, and solutions, specifically looking at the intercepts here, are going to be 5 and -3, the opposite of what I visually see in those parentheses because P and Q are the opposite. Okay, and now we know all this because we have -2 open parentheses x minus 5. and x minus -3, right? Minus a minus is plus, which is why we see a plus sign in the highlighted black intercept form equation that I wrote up at the top. So that's a very long-winded way to say, when we see intercept form, it's just like factored form, and the solutions, or the x-intercepts, are just the opposite of what you see. So here's where we put a couple things together that we've already done. Now we're going to be focusing on those solutions, not really necessarily the transformations, but we're going to identify the zeros of the quadratic function. Remember, the zeros are going to be p and q, but the g of x function that's given to us right now, that's in standard form. The good thing, we know how to change it into factored form, which is also intercept form. Now, when we learned how to do intercept form, I made a big fuss about making sure that it always says equals 0. Y'all remember that? Like, I was like, if it doesn't say equals 0, you can't start. Well, like, yes, obviously this one's not going to say equals 0 because it's actually equal to the name of the function, g of x. That's okay. So now you have two rules. If it says equals 0, you can factor it, or if it says equals to f of x or g of x or h of x, you're good to go. We can go ahead and factor this polynomial, this quadratic, and see what intercept form or factored form looks like. There would be a 20 at the top, a 9 in the bottom, and 1 in the denominator. The numbers that would multiply to 20 and add to 9 are what? Yeah, 4 times 5 is 20, and 4 plus 5 is 9. So that means that factored form, which now we know is also called intercept form, is going to be x plus 4, x plus 5. But remember, the roots, zeros, x-intercepts, and the solutions are the opposites from your factored form, which now, again, we can call intercept form. So to fill out the sentence underneath here, we can say that the roots, zeros, x-intercepts, and solutions of this function occur at -4 and -5 because that g of x function factors to x plus 4 and x plus 5. And the roots and zeros, x-intercepts, and solutions are the opposite of factored form, or intercept form now. Cool. I want y'all to try number 2. I'm going to pause the video, and I'm just going to end up showing you the answers here. So go ahead and pause the video. Try to factor this polynomial. It's set equal to h of x, so we're good to go. And tell me what the roots, zeros, x-intercepts, and solutions are. All right, so here's what I got. I went ahead and factored this where -12 is on top, 11 in bottom, and 2 is underneath. The numbers that would solve the x puzzle are -1 and 12, because -1 times 12 is -12, and -1 plus 12 is 11. I reduce this fraction to 6, and I reduce this fraction, but it doesn't actually reduce, so I leave it as -1/2. Don't skip this step, because we need to see what the pre-factored form, I'm using air quotes and you can't see me, pre-factored form is, so we know what the fraction solutions would be, or the fractional x-intercepts. But when I fill in the sentence, I do need to go ahead and swing that forward, because intercept form and factored form don't need fractions. So the roots, zeros, x-intercepts, and solutions occur at 1/2 and -6 because this is factored or intercept form. So again, it's going to sound really familiar to what we did before spring break in solving by factoring, because it is. We're just actually applying it to a form of a quadratic. All of this stuff is interrelated. Roots, zeros, x-intercepts, and solutions. Now, not only can I look at the equation and tell you the root, zeros, x-intercepts, and solutions, I can be given the rocks and create intercept form equations. We're going to be writing these quadratic functions in that factored or intercept form given the conditions that is shown. Now remember, intercept form is going to be some variation of f of x equal to a x minus p, x minus q, where p and q are the rocks words. Great, so number 3 says, here's your information you have. You know that the solutions are -4 and 7. Well, that's P and Q, so this would be f of x equal to, it doesn't tell me anything about a, so I'm going to kind of like skip a, and I'm going to fill in the P and Q that they gave me, x minus -4 and x minus 7. But we never leave things as minus and minus. Again, they're the opposite. So this is going to be x plus 4, x minus 7. That's why they're opposites. This is a quadratic function that meets the conditions that are given. I don't have to stretch or shrink it or flip it because it doesn't tell me to. You guys try number 4. What is the intercept form equation that meets these conditions? Hopefully that didn't throw you off because it says the zeros are -2 and 5. But remember, the zeros are still a part of my rocks words. So even though we've used 2 different vocabulary words, we're still talking about the x-intercepts. We're still talking about P and Q. Great, now what if I give you information like numbers 5 and 6? This time it's not in words, we have a graph. Okay, first thing I want you to notice about number 5 is that it has 2 places where it crosses the x-axis. That means it has how many solutions or how many x-intercepts? Yeah, 2. So we already know what P and Q are. P is going to be 0 and Q is going to be 6 because that's where they cross. So if that's P and Q, then I know that my function f of x can be x minus 0 and x minus 6. Now you won't see this as an answer choice because this right here, x minus 0, can be simplified. If you wrote that for me, I'd count it correct, but really answer choices are going to simplify that just down to x and x minus 6 because x minus 0 is still x. Now what's cool about number 6, I like the number 6 problem a lot because very obviously we can see P and Q, like they even put the little dots on there. But do you notice what kind of parabola this is? This is a sad parabola, which means we should reflect in the x-axis. The way that we do that is by making the equation negative. So not only am I going to use P and Q the way I've done before, where it's the opposites, x plus 9, x plus 2, I'm also going to make this whole equation negative to reflect it because it's a sad parabola. Now we're back to it being kind of simple. On number 7, it says the roots are 3 and -3. Those are the roots. That's part of my rocks word, so we know that that is the intercepts, so we can plug them into intercept form. It doesn't tell me anything about a reflection or a stretch or a shrink, so I don't have to do anything with that first value like I did in number 6. But in number 8, it does. Number 8 says the solutions are 1/5 and -9, and it's a reflection in the x-axis. So we're going to have some information to deal with the intercepts, and we're going to have to make it reflect in the x-axis. But that's easy because you just make it a sad equation to make it a sad parabola. So here we go. F of x is equal to the sad parabola, so I'm going to make that negative, where the intercepts are 1/5 and -9. Now remember, to really be done with this question, we are going to have to swing that denominator forward since we do have a fractional solution. So really, the intercept form is f of x equal to -5x minus 1 and x plus 9. And that is an intercept form quadratic that meets these conditions, that it has those solutions and it's a reflection in the x-axis. See y'all in class.